Hello, thank you, Bill, for inviting us to present today. This is our first time at AUSA, and I'm going to talk today a little bit about our energy and UAV systems for military and commercial applications. H3 Dynamics is a company that brings together complementary technologies to solve complex solutions for our customers. And we are a vertically integrated company. We develop endurance power technologies, unmanned systems, and data analytics. And I'll be discussing our endurance systems and unmanned systems today. We're a global team across the globe. Our headquarters is in Singapore. We are located, the US division is in Austin, Texas, and we have sales, engineering, and product development in several other countries. Oops. Sorry. I was advancing the wrong portion. Here we go. At HES, we focus on high performance energy storage solutions and hydrogen fuel cell technologies in general, along with hydrogen storage technologies. The demand for power, whether it's military or commercial, is growing every day. There's not a day that doesn't go by when someone tells me about a new application, but they don't have the power to run it, and they need different solutions. So that's where we come in to provide those solutions for future applications. The challenge with developing fuel cell solutions is not just the fuel cell, but it's the hydrogen storage associated with running the fuel cells. And we've worked to remove that barrier by developing chemical hydrogen storage solutions that generate hydrogen on demand through the use of water and catalysts, and as well as developing new compressed gas solutions. The cartridges we develop contain no free hydrogen. They're all chemically bonded, so they are safe for fire, for dropping, transport, things like that. And the dry systems have shelf lives of 5 or more years. The cartridges can be considered a consumable item, much like a primary battery, and not so much as a fuel, because they are a self-contained unit. They can follow the same infrastructure and shipping methods as common batteries. For remote sustained applications, we work with methanol solutions. And this is due to the high energy content of methanol and the fact that it's a liquid fuel. It's easier for people to understand after working with gasoline and diesel. It's just another liquid fuel, and it has very high energy density. The fuel cells are a great solution, but they're not the solution for every application. But one of the most promising applications is in the world of UAVs. They can provide significant advantages over the current lithium-ion batteries. The biggest advantages over batteries is its specific energy. We are 2 to 3 and sometimes 4 times as great as the most advanced lithium batteries. There's also no recharging time. If you're using a cartridge, it's a replace, just like replacing an ink cartridge. Pull out a used one, put in a new one, throw the old one away. They're completely disposable. There's very low noise, very low heat signature, low to no EMI. There's very few moving parts, so there's very little maintenance, and that's how we generate such little noise. There's no harmful emissions. They don't generate CO2 or, more importantly, CO, and they're twice as efficient, at least, as combustion engines. This is a summary of our product development profile and application path. It starts at the fuel cell stack, works its way into fuel cell systems, and at any point the customer can purchase along here, and we provide these type of systems from universities all the way up to military clients. But from there they can choose the type of hydrogen storage they want, whether it's methanol, chemical, or compressed gas, and that's all driven by the end use application. These two graphs just show graphically where we fall in the world of energy storage in relation to lithium batteries. You can see on the graph on the left, the 3 stars are where we currently are with our hydrogen storage technology, whether it's a solid storage, liquid storage, or others that we're working on, other chemicals. You can see they're at least twice the specific energy of the current lithium-ion batteries. And as far as the Department of Energy is concerned, we are well within their goals, their 2015 goals for energy storage for hydrogen fuel cell applications. We have a history of breakthroughs and technological advancements in the world of UAVs. We've worked with a number of companies all over the world. One of our most recent breakthroughs and triumphs is a UAV that we worked on with ST Aerospace in Singapore based on our hydrogen on demand system. The display I have up here on the table is an actual replica of the power system that was used in this UAV. We were able to have a flight time of nearly 6 hours, a distance over 200 miles, all with a fuel cartridge that contains 1 kilowatt hour of energy. And the fuel cartridge is the silver cylinder on the end. So in a 1 liter space, approximately 1 kilogram in weight, we store 1,000 watt hours of energy. I wasn't advancing far enough. I'll let you have a moment to read this. The Skyblade 360 is a product that they are currently developing, and we were half the weight of their normal lithium ion package. We also develop soldier systems. We take our advancements in lightweight technology and endurance and miniaturize it into something a soldier can carry to either recharge secondary batteries or run equipment. The biggest advantage here is hot swappable cartridges. There's no recharge time, and we reduce the amount of weight and volume that they need to carry for a 72-hour mission. Once again, there's no CO or CO2 emissions, so it's safe to use indoors or inside of a vehicle. We've also worked on ground robots. Although weight is not typically as important as in an aircraft, the volume is. And so we've worked with a few universities with their robotics programs. One was for the DARPA challenge using our technology. The most common form of hydrogen storage for fuel cells is compressed gas, and we're also leading the way and exploring new ways of storing hydrogen gas. This long tube, which we have on display at our table over there, is what we call structural hydrogen storage. These long tubes can be manufactured at any length and be used for a number of different structural elements of an aircraft. For example, fuselage, tail boom, wing spars, and the frames of multi-rotors, which was the original inspiration. Most multi-rotors are made of tubular carbon fiber material, so why not turn those tubes into storage? And then in the world of stationary type applications, this is where we use our methanol-based fuel cell systems. The advantage with methanol is it has 1,000 watt hours per liter of fuel. So we have a device called DRONEBOX, which is a remote communications and energy storage system based on methanol. It's a hybrid system tied with solar, so the majority of the time it can be powered by solar, recharging internal batteries. But in locations where there's either not enough sun or particular times of the year, when there's not enough sun, the fuel cell can take over and maintain operations. A system like this can run for a year or more without maintenance or needing to be refueled. Some of the applications include field sensors and electronics, remote ISR, communication stations, security cameras, APU, and eventually powering our DRONEBOX solution, which I'll show you here shortly. Along with this methanol technology, we're working our way into larger reformed methanol systems for the new and upcoming electric aviation industry for small manned aircraft. This technology is well suited once again because of the energy density of the methanol. 1 liter of fuel is equal to 5 kilograms of LiPo batteries. The other division of the company is HUS. This is our Unmanned Systems group. We apply the capabilities of our lightweight systems into UAVs in new ways and design UAVs to accommodate fuel cells for quicker adoption. This includes multi-rotor, fixed-wing, hybrid VTOL type applications, and the development of a new leave-in-the-field automated UAV system, which I'll show you here momentarily. I'll have a video. One of the examples of our UAVs in development, which incorporates our structural hydrogen storage, is what we call HiCopter. The main structural elements of the HiCopter are our hydrogen storage cylinders. The goal of this program is to develop a 1 meter multi-rotor platform capable of carrying a payload of at least 1 kilogram with a flight time of over 3 hours. And DRONEBOX is our latest product that was unveiled at the Singapore Air Show last month. We consider this the beginning of the Internet of Drones. This is Internet of Things technology. It's a deployable nesting system and sensor package for a wide range of applications. So let's go ahead and show the video. So that's our DRONEBOX solution, and that'll be available this summer starting in June. And one of the things that it showed in that video was a tethered version. That will be one of our first available versions. As a tether, it's essentially a powered kite, and it avoids all the FAA regulations and other regulations for safety that are currently in place, that until the FAA makes some future decisions on how to manage our airspace with these vehicles, that is an option for countries with restrictions. Along with that, it showed in the video that we can combine this with our REMOBOX together to provide reliable endurance power and extended communications out in the field for very remote locations that may not have enough sun or need more power to communicate by satellite or long distance RF or Wi-Fi or things like that. So as we move forward at HUS, some of our ongoing research includes collision avoidance for DRONEBOX and our other UAVs, long-term off-grid operation, including newer developments of REMOBOX, swarm and collaborative networking between multiple DRONEBOXes to work together and use multiple nests so the same drone doesn't have to return to the same nest every time. And they can work together to take video or sensor readings in natural disasters or pipeline inspection or wind turbine inspection, a number of different things, so they can all work and join together to accomplish tasks quicker. Improvements on wireless battery charging. I mentioned the tethered operation. We're working on lighter tethers so we can go even higher. And then a number of new unmanned aerial systems on the way. So I'd like to thank you for your participation and paying attention, and I'll open to some questions.
So Mark, in your DROIDBOX, at least in the demonstration, the drone is not fuel cell powered, correct?
No, the small drones are still battery powered.
Okay.
They're a little bit too small to incorporate fuel cells, but they can be recharged with fuel cells.
Okay.
And on the tethered version can run from a fuel cell when they're just combined with the REMOBOX.
Yes.
So you can stay in the air for hours at a time.
Okay.
Just at a lower altitude because of the tether.
And so the DRONEBOX would only work with your proprietary drone, or?
No, it's a power source.
Okay.
It could work with anything. It can output whatever voltage the customer needs.
Okay.
And be turned on and off as needed remotely.
Excellent.
Thank you. Anything else? Okay.